In the last video, we spoke about why we are seeing these errors inside the sorter. Before we move on, however, I want to just very quickly look at one more diagram to make sure it's super crystal clear why we are seeing these problems. Okay, so here's the issue. It really comes down to expectation versus reality. TypeScript is always going to analyze your code and look at every class in isolation and try to make sure that it works. So TypeScript is currently looking at sorter. It looks at the sort method, and it sees that inside there are references to swap, compare, and length. So TypeScript makes sure that swap, compare, and length exist on sorter, but they don't. And so we are seeing red errors around all those different references. So this is what TypeScript thinks is happening inside of sorter right now. This is what it thinks is going on with our program. But this is not reality. This is just what TypeScript is kind of expecting. It's expecting the worst case scenario. The reality that you and I know is that we are never going to create an instance of sorter directly. Remember, that's what we were doing before inside of index.ts, but we said that having to create this instance right here was a big pain, and we didn't want to do it anymore. So we're never going to create an instance of sorter directly. Instead, we are only going to extend or borrow methods from sorter. So again, we imagine that we are copy-pasting sort down to numbers collection. And in this context, sort can refer to this.swap, compare, and length without any issue, because those properties exist on numbers collection. So again, it's an expectation versus reality kind of deal. So we need to make sure that TypeScript understands what the reality is. That's the only thing here. So in this video, we're going to talk about how we're going to modify the sorter class to help TypeScript understand what reality is. So to fix the problem, we're going to turn sorter from a normal class into something called an abstract class. So let's very quickly talk about what an abstract class is. First off, most importantly, an abstract class cannot be used to create an object directly. What do I mean by that? Well, normally when we create a class, like with the normal sorter that we had before, or actually rather than referring to sorter, let's refer to numbers collection. We created a class called numbers collection, and then back inside of index.ts, we used numbers collection to create an instance out of it. So we've got a variable right here that refers to an instance of numbers collection. When we create an abstract class, we can no longer do this. This is not allowed. That is totally okay in the case of the sorter, because remember, we just said we don't want to create an instance of the sorter anymore. So when we turn sorter into an abstract class, we will no longer be able to write lines of code that look like exactly that right there. Next up, abstract classes can be only used as a parent class. So whenever we create an abstract class, it means there are going to be some set of methods on it that we want to make available to other classes for inheritance, or essentially to copy-paste those methods somewhere else. Now, of all those methods, some of them can be real implementations. What do I mean by that? Well, let's go look at our sorter once again. Inside of sorter, we've got a real implementation for sort right here. In other words, there's a body to this function, and it contains some very real code that we definitely want to execute. However, it has references to methods that don't exist. So in an abstract class, that is okay. We can have references inside of some implemented methods to other methods that don't actually exist yet. The only requirement is that we have to write out the names of those methods and their signature types, like the different arguments they take and the different types they return inside of the abstract class body. So in other words, like right here, we just have to write out a listing of all the methods and types for them that we expect to eventually exist inside of sorter. Now, when I say eventually exist, by that I mean those kind of stubs of sorts that we're going to write out. We're essentially saying that any class that extends our abstract class has to promise to implement those methods. So child classes have to promise to implement the methods that we said will eventually exist in the future. And so as you might imagine, this solves our problem perfectly. This is the exact scenario that we are in. So here's what's going to happen. We're going to turn sorter into an abstract class. It is going to have a real definition for sort, or a real implementation. Abstract class will then be used as a parent class to characters collection. So again, we imagine that we are copy-pasting sort over. TypeScript is then going to try to evaluate sorter in isolation. It's going to say, okay, I'm going to check out this class by itself and make sure that it has good code. Then inside the abstract class, we are going to provide stubs or some like little information about the length, compare, and swap methods. So we're going to tell Typescript that these are going to eventually exist. And by doing so, Typescript can evaluate the sort method and make sure that all the code in there is technically correct. And then finally, when we extend characters collection with sorter, Typescript is going to look at characters collection and say, okay, you can copy paste that sort method over, but if you do so, you better provide an implementation for length, compare, and swap, and they better have the appropriate type signature. If they don't, we're going to very quickly see an error. All right, so that's pretty much it. Like I said, abstract class perfectly solves the scenario we are in right now. We never expect to create an instance of sorter. We just want to borrow one method from it, but unfortunately, that method has references to some other methods that don't yet exist and need to be customized by the child class. Again, as you might imagine, characters collection is going to have one implementation of length, compare, and swap, and on numbers collection, we need to have a different implementation. So we are making the child class promise to implement those different methods. All right, so now that we got a better idea of what's going on here, let's take a quick pause. In the next video, we're going to turn sorter into an abstract class.